Hi everyone and welcome to the Learning Curve. In this video we have two interesting questions that we'll be looking at, continuing my series on looking at geometry questions which are a common part of high school curriculum as well as middle school curriculum for students studying geometry and pre-algebra. Now, in the first question here we are told that in this figure, line AB, here we have line AB, is parallel to line CD. So this is what this notation here means right here. These two lines means that AB is parallel to CD. As we see here, AB and CD are parallel because there are two lines running alongside each other and they will never meet. So they are parallel lines. We're also told that EC here, EC and ED are perpendicular lines. So this is what this notation here means, that EC and ED are perpendicular lines. Perpendicular lines form a 90-degree angle where they meet. So this is 90 degree right here. We know this because of the fact that we are told that these two lines are perpendicular lines. And perpendicular lines make a 90-degree angle at the point where they meet. So this angle here is 90 degrees. We are told to find x, and we should show all working. So this is x right here. So we're going to apply some important angle properties in order to find x. First thing we need to realize is that angle x is a vertical angle to this angle right here, which is angle D. So angle x is a vertical angle to angle D. So in other words, because angle x is a vertical angle to angle D, it means that angle x is equal to angle D right here. Yes? So whatever angle D is right here, it's the same as angle x. Moreover, we realize that angle D would be equal to angle B. So angle D is equal to angle B. And this is so because we realize that these are corresponding angles. Angle D and angle B are corresponding angles. This is so because they are on the same side of the transversal line here. The transversal line is a line that cuts the two parallel lines. So angle C, angle B rather, and angle D are corresponding angles because they are on the same side of the transversal. One is within the two parallel lines and one is outside of the two parallel lines. So these are corresponding angles, and corresponding angles are equal. So if we are able to find angle B, then it would mean that we would have the answer for angle X, because angle X is the same as angle D, because these are two vertical angles here. Vertical angles are equal. Angle X and angle D are vertical angles, so they are equal. And moreover, angle D is equal to angle B because angle D and angle B are corresponding angles. So that being the case, once we can find angle B, then that would be the answer for angle X. Now we know that angle E here is 90 degrees because this is the point where the two perpendicular lines EC and ED meet. So if we can determine this angle here, then we can easily add this angle to 90 degrees and subtract from 180 to get angle B, because the total interior angles of a triangle add to 180 degrees. So let's set that out. We're going to try to find this angle here, angle right here. We're going to try to find this angle. And what we realize is that this angle, which I'm going to call this angle right here, angle Z, I'm going to call that Z. We realize that angle Z and 132 degrees form linear pairs because they make half of a circle on a straight line. So I'm going to make a statement here to say angle Z plus 132 degrees must give me 180 degrees, because angles on a straight line forming half of a circle, they are linear pairs, and linear pairs add to 180 degrees. So Z, angle Z, plus 132 degrees will give us 180 degrees. So to find angle Z, we will simply subtract 132 degrees, which is added to angle Z. We want to get angle Z on its own. And because 132 is added to angle Z, we will simply subtract 132 from the left side of the equation. But what you do to one side of the equation, you have to also do to the other side in order to maintain balance. So we're going to subtract 132 from both sides of the equation, so it will be gone on the left side, leaving us with Z only, equal to 180 degrees, take away 132 degrees. So 180 take away 132, and that is going to give us 48. So 48 degrees is angle Z. That's the angle right here. Now we know angle Z is 48. So let me just put it here. Angle Z is 48 degrees. And we know that angle E here is 90 degrees. So we know two of the three interior angles of the triangle here. We know angle Z, 48 degrees. We know angle E, 90 degrees, but we don't know angle B, which is what we want. Because once we can find angle B, then it will be the same as the angle here, X. So what we know about the rules of a triangle is that the total interior angles of a triangle add to 180 degrees. So that is angle Z, the measurement of angle Z here, plus the measurement of angle E, which is where the 90 degrees is at, plus the measurement of angle B, which is what we want, should give us 180 degrees. So now we can find angle B because we know that Z is 48 degrees. We know that E is 90 degrees because of the perpendicular, but we don't know angle B. We don't know the measurement of angle B, but we can now easily solve for it because it's the only unknown in the interior, among the interior angles of this triangle right here. So when we add 48 degrees to 90 degrees, we get 138 degrees. So this will be 138 degrees plus angle B, and this will be equal to 180 degrees. So now, since we have 138 added to angle B, we're going to get rid of that 138. We're going to get rid of this positive 138 by doing the inverse of addition, which is subtraction. So we're going to subtract 138 from the left side of the equation. What we do to one side of the equation, we'll also do to the other side. So 138 minus 138 here is going to give us 0, leaving us with angle B on the left side of the equation. And on the right side of the equation, we have 180 minus 132. 180 minus 138 rather. Yes, 138. We're subtracting 138 from both sides. So we have 180 take away 138, which is going to give us 42 degrees. So the measurement of angle B is equal to 42 degrees. And since the measurement of angle B is the same as the measurement of angle X, then we know that angle X is equal to 42 degrees. So I'm going to say, therefore, the measurement of angle X, which is what we want to find, is equal to 42 degrees. And that's the answer for this question. Awesome. Now let's look at the second question here where we're also asked to find X. Now looking at this question, we realize that none of these two lines, we have two parallel lines. This line is parallel to this line. But we do not have a transversal fully cutting both of these lines, because a transversal has to be a straight line cutting through two parallel lines. So what I'm going to do is that I'm going to choose to extend one of these lines here to form a transversal. So I'm just going to use dotted lines. I'm going to choose this one. Either will be fine. I'm going to use dotted lines to extend this line. So I now have a transversal line cutting through this entire line from here to here, which I have extended, because we can be creative and extend a line in this kind of way to allow us to make the solution of the problem easier. So now I've extended one of the lines here to form an actual full transversal, which is a line cutting through two parallel lines. Because there are several rules that surround situations where a transversal line cuts through two parallel lines, it makes it easier to solve for the angle that we're looking for. And the angle that we're looking for here is angle x. Right, so this is really what we're looking for here, angle x. All right, so let's work towards angle x. First of all, we're going to apply some important rules here, which the transversal allows us to do. We realize that this angle here, I'm going to use blue, realize that this angle here will be the same as this angle here. Why? Because along the transversal, these two are alternate interior angles. And alternate interior angles are equal. They are alternate interior angles because they are on opposite sides of the transversal and they are within the two parallel lines. So that's what makes these two angles here, this angle and this angle, alternate interior angles. Alternate meaning on different sides of the transversal, and interior because they are within the two parallel lines. So therefore, these are the same. So what we know further is that angles on a straight line form what we call linear pairs. So continuing with this angle here, continuing with this angle around here, we now know that 130 degrees plus whatever this angle is at the green area, whatever at the green arc, these should add to 180 degrees. So I can get this angle right here by subtracting 130 from 180, because this angle right here at the green arc plus 130 degrees form linear pairs because they are angles on a straight line forming half of a circle. So if I can subtract 130 from 180, it will give me this angle right here, because again, these are linear pairs and linear pairs add to 180 degrees. So the angle here formed at the green arc right here is going to be 50 degrees, which is 180, take away 130 degrees. So I know that this is 50. I know that this is 66 right here, 66. So I only have one missing angle here, which is this angle. So we can now easily find this angle here that I've made here at this arc, because we know the property that the total interior angles of a triangle add to 180 degrees. Since the total interior angles of a triangle add to 180 degrees, we're going to simply add 66 degrees plus the 50 degrees that we found here and subtract from 180 because there's a triangle right here. Yes? And the total interior angle is this plus this plus this should add to 180 degrees. So basically, I'm just going to take, to find the angle right here formed at this arc, I'm going to simply take 180 degrees minus 180 degrees minus 66 plus 50. Right? Minus 66 plus 50. And that's going to give me the missing angle right there. Alright, so let's see what this gives us now. 180, take away 66 plus 50. Now 66 plus 50 is going to give us 116. And then when we take 116 from 180, we get 64. So the answer here is 64 degrees. So what do we know now? What we know is that the angle at this green arc right here is 64 degrees. And since we realize that the angle at this green arc makes half of a circle with angle x right here, which is what we want to find, and we know that angles that form half of a circle on a straight line adds to 180 degrees, it means that this angle formed at this arc, 64 degrees, plus angle x will be equal to 180, because they are two angles that are formed on a straight line and they make half of a circle. So to find angle x here, I'm going to simply say that angle x is equal to, yes, 180 degrees, because angles on a straight line that make half of a circle, as these two angles here do, will add to 180 degrees. So I can take 180 degrees minus the 64 degrees, and it's going to give me the answer for angle x. So 180 take away 64 degrees, and when I take 64 degrees from 180 degrees, I get the answer, which is 116 degrees. Yes, so 180 take away the 64 degrees here gives us 116 degrees. So that's our answer. 116 degrees is angle x. Another way in which we could have found this 116 is using the fact that an exterior angle formed at the vertex of a triangle, which angle x is an exterior angle, formed at this vertex, is equal to the sum of the two opposite interior angles. The opposite interior angles from this point are 50 and 66, which gives us 116 as well. So that's an alternative way in which we could have found angle x once we have found this missing angle right here. That's our answer. Angle x is 116 degrees. I hope you found this to be very informative and very helpful as you continue the journey in mastering all things mathematics, and especially in this case, the geometry of angles and lines. Thank you. Remember to like, share, and subscribe. See you soon.